Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 13, the 13th episode. Hello, it's been a while since I streamed. I streamed once last week and then I was visiting home, haven't had the time. I'm still kind of exhausted, but here we are. We're gonna solve some Code Katas tonight. In the description of the video, I have a link to the katas that I plan to solve. And if you're not familiar with this stream, you can visit github.com/codinggarden/code-katas. You can see all of the previous episodes and previous katas that I've solved, and all of the code that I write tonight I'll push up here, and you can take a look at it there. Hello everyone, hello, welcome to the stream. If you're watching live, throw a message in the chat. Hello Dan, welcome. Mr. Unknown, Amy, Merchan, Winkle, Skelly. Hello. Okay, so the ones, I have 4 picked out tonight. I was gonna say I might do more. I'm gonna stick to these because they'll probably take me longer than I think they will. I'm gonna start off with easier ones and they'll get gradually harder. So the first one is a problem called printer errors. This is a 7Q. The next one is sum of the first nth term of series. This is also a 7Q. Then we have find the parody outlier. This is a 6Q. And then lastly, we have first non-repeating character, and that's a 5Q. Oliver Wright, hello, welcome. Hey them. Coding Train says, nice microphone. Appreciate that. I got that probably like 2 weeks ago. And Maddie Max, hello, and welcome. Yeah, this is the Blue Yeti. It's working out. I was using a USB audio interface before with a condenser mic plugged in, and I had all kinds of issues. This just plugs in via USB. It works great. Okay, let's do this. I feel like I might be a little rusty, but I'm ready. Okay, so this one is called printer errors. In a factory, a printer prints labels for boxes. For one kind of boxes, the printer has to use colors, which for the sake of simplicity are named with letters from A to M. So valid colors have names from A to M. The colors used by the printer are recorded in a control string. For example, a good control string would be AAA, BBB, H, AI, JJJ, M, meaning that the printer used 3 times color A, 4 times color B, 1 time color H, then 1 time color A, etc. Sometimes there are problems, lack of colors, technical malfunction, and a bad control string is produced. In this case, AAA, X, BBB, YY. The main thing here is we need to detect any letters that are not A through M. So if it's out of the range of A to M, we know that this is an error. So we're gonna write a function that takes in that control string and decide whether or not an error happened. So for instance, if we get this control string, we should return 0/14 because there are no errors in that string out of all 14. And then if we get this string, we should return 8/22. Cool. Let's do it. So I'm going to take this code down locally. Mansumi, which is Oliver Wright, mentioned that they were getting 500 errors on Code Wars. I'm going to do everything locally, and then we'll try to submit afterwards. Let's create a new file. What are we going to call this? Printererrors.js. And we'll write our function. We'll bring the test down locally. We'll throw those other examples in there too. Okay. Let's make this a const. So we have this, and in this big long string, X, Y, and Z are the only characters that are not within the range A to M, so our return is actually 3/56. I'm going to start up Quokka, which is a plugin that will actually run my code inside of VS Code, so that's cool. And right now, our function is returning undefined because we're not actually doing anything. So let's think through this. There are a lot of different ways to solve this. We could probably use a regular expression. I think the first way I'm going to solve this is just iterate over the string. So we're going to iterate over the string. We'll say if the current letter is not within the range A to M, then we'll need to increment some sort of count. So to begin with, we need a place to store the number of errors. And then if the current letter is not within that range, then we will increment the number of errors. And then after all of that is done, we will return the number of errors over the length of the string. Pretty simple logic. The one tricky thing we might run into here is how do we determine that it's within the range a to m? We could use a regular expression for that. There is a regular expression that says, does this match a through m? We could also look at their ASCII codes. So we could look up what are the ASCII codes for A and M and make sure that the ASCII code of the current letter is within that as a number. Cassandra, hello, welcome to the stream. And Ran. Oh, and Maddie 01234567889, first live stream watching. Awesome, welcome. And Edgar's, it is 1 a.m. there. Welcome to the stream, hope you get some sleep. But yes, this is our logic. Let's start to write it, and then we'll decide what we're going to do here. It's either going to be a regular expression or like checking the Unicode, not Unicode, Unicode? Char code, character code values. Okay, so we need a place to store the number of errors. So let's just say errors starts off at 0. Then we need to iterate over the string. So let's create a for loop. It goes from I is equal to 0 while I is less than the length of the string. This is my break timer. We're just getting started, but if you're watching from home, maybe stand up if you've been sitting down for a while. I have been standing up all day, so that's why I'm sitting down. Okay, so I is less than string.length, I is incremented, and then we'll do this stuff inside of there. So if the current letter is not within the range a to m, let's go with the character code route this time, and then we'll do it again maybe with a regular expression. So let's look up JavaScript character codes. Hey, look at that. There's an ASCII table. Show more. Thanks, DuckDuckGo. Let's see. So we have hex, octal, HTML, char. I don't know if this is actually what I want. Let's see if there's a result that I can find. Maybe something on MDN. JavaScript char codes. There's W3 schools. Let's see what this gives us. So I want the char code for lowercase. Wait, a. No, it's automatically uppercasing it. Okay. Lowercase a has a value of 65. Actually, I think that's wrong. Hello, Alariza. Welcome to the stream. Wes Boss actually made a tool. I think it's like keycodes.com. Hopefully that's a legit thing. Maybe it's charcodes.com. I'm going to Google this. Wes Boss char codes. Keycode.info. Press any key to get the JavaScript event keycode. Okay, so A is 65. Oh. Wait. It's not I don't want the key code, I want the char code. Is that the same thing? Let's try it. So if I open the DevTools and I say, if I do string.from charcode 65, I get a capital A. I want a lowercase a though. Let's look at our, maybe, is it Unicode values? You know what I could just do? Dot char code at 0. $97. Okay, so I don't know why I didn't do that to begin with. So A is 97, and then M is 109. So if we make sure that the current letter is between 97 and 109, we're good to go. Okay. So if, let's store the current letter. This is going to be S at I, that's the current letter. And then really we could get just let's say current letter code. And this is going to be s at I dot, actually, I don't even need to get the code. I think we can compare it straight up. JavaScript will do it for us. So we'll say if current letter is greater than or equal to 97, and current letter is less than or equal to 109, then number of errors goes up. And just the way comparison works in JavaScript, if you give it a string, it automatically turns that into the char code under the hood. So then we'll say errors plus plus. And for now, let's just log, if it's not between these. So if it's less than or equal 97, and if it's less than 97 and it's greater than 109, then we know that the current letter is an error. We'll increment errors, and then ultimately we will return a nice little template string with errors over the length of this input string. Let's see what we get. Right now we're getting 0 out of 56. Why is that? Okay, let's look at what is the character code for like the letter X. 120. This should be an OR. So thank you, Oliver. So Oliver mentioned A is 97, M is 109. So I tried that in DevTools, charcode at, let's see. So yeah, that's what I tried. Oh, interesting. Mert Chan is mentioning, can I just do less than A and greater than M? Yes, I can. That's way too easy. Okay, so that actually does it. And this is just because JavaScript automatically, like if you're comparing two strings, it converts it to their character codes. Wow, I didn't even have to do any of that. And yeah, Merchan was mentioning this needs to be an OR. So if it's less than A or greater than M, we know that it's not within the range. So we increment our errors, and then ultimately we return the errors. Great. Okay. That was a little rough. I'm a little rusty. But let's do it again, but let's do it instead with a regular expression. So instead of matching it against A, like less than or greater than, we should be able to just say current letter dot match, and then we have a regular expression that's just A to M. And we'll say if it doesn't match that, return that error. So this works in exactly the same way, but instead we're just essentially matching that single letter with the range A to M, which that's how a regular expression works. Cool. So that also works. I'm thinking though, instead of iterating over the whole string, we might actually be able to just do a single regular expression that gives us anything in the string that's not A through M. So let's try to do that. So that's easy enough. Let's get rid of my console logs. Get rid of the comments too. And then I'm thinking, is there a way that we can write this with a reduce maybe? I mean, the regular expression is probably going to be like a one-liner, but let's see. So let's say errors is going to be current letter dot match A to M. Oh, sorry, S dot match. So this is going to match every single letter in every single letter in the string that is A to M. So we might have to flip this. Let's just call this matches. And then if we log this, what do we get? So we need to make it a global expression, because right now it's only matching the first A. But if we say global match every single thing, then we get an array that has all of the matches in it except for XYZ. That's great. But what if we say not this? Getting null. Maybe that's not how that works. So I want to say anything that isn't within the range A through M. Let's Google it. So I need a regular expression for not in range. Oh, that's why. Regex is, that's not a not, that's a not. Ah, okay. And the not goes inside. Look at that. So easy. So this regular expression matches anything in the string that is not A through M. And in this case, it's XYZ. So let's call these errors. And the thing that we return is errors.length over string.length. Look at that, 2 lines. We probably could even write this all on 1 line. Let's see that. So we could do string.match.length, and all of this goes right here inside the template string, and then all in one go. Very interesting. Yeah, thanks, Oliver. The hat is what I need. So this is the not in regular expressions. I was using the not that we use in JavaScript. Green Coder says, I don't understand anything. Well, if you're new to coding, regular expressions are definitely not the place to start. This function is probably a lot more approachable as a beginner because it has some basic iteration, some basic comparison, some incrementing. This is maybe a little bit advanced if you're not familiar with template literals, but it's doable. Interesting. So JT is mentioning you can also subtract the matches from the whole length to get the mismatches. So let's do that. So basically we'll invert it. So this is grabbing the not matches, but we could also, here I'll write it down below. Wait. That's exactly the same. So here I'll write it. Let's grab the matches, and then I guess do we call these not errors? Let's just call these matches. And the errors are going to be s.length minus matches.length. So this does the reverse. So the regular expression matches everything that is not an error. Is there a better variable name for that? Like, what is this? These are good. Good controls, good strings, bad strings. Let's call these goods. And so then we return the total length minus the length of the things that are good over the length. And so this works basically in the same way as this, but we're just not getting the knotted. Cool. Okay, that was fun. I'm a little rusty. I could feel it. Like I was panicking at the beginning. Like, how do we find char codes? But that was fun. Can anyone think of other ways to do this? I'll take a look at the chat. Oh yeah, I did mention, could we do this with a reduce? I think we could. I think we could reduce the string to the number of errors and return that over the length of the input string. I think I'm going to do that really quick. Let's do that. So far, if I had to choose a winner, I would probably choose the one that is the regular expression, because it's you have to think about like the people that you're coding with, like, do they understand regular expressions? And if they do, this makes it a very clean and short solution. But let's see. So let's try to do this with a reduce. Now, when you're turning something like this into a reduce, you typically can keep what you have inside of the for loop, but everything else changes. So basically, we're going to reduce this string down to errors. So here's what we'll do. We'll say, first we have to split the string into an array because reduce only exists on arrays. So we'll do string.split on the empty string. We now have an array of all the characters in the string, and then we'll reduce it. Our accumulator is going to be the number of errors, and the second parameter is each value inside of the array. So let's just call this, well, actually we can call this current letter. And then we have our function, and then we have where does our accumulator start? And in this case, our accumulator starts at 0, so that goes there. So now what I'm doing is I'm calculating the number of errors in this reduce function. And now, instead of having to grab the current letter, really all I have to do is take this code from inside the for loop, put it inside my reduce, and then return errors. So we've basically taken the for loop and turned it into a reduce that is reducing down to the number of errors. And really, if I wanted to write this as all one go instead of like on multiple lines, let's do that here. So I could return this plus slash plus s.length. And so this whole expression calculates the number of errors, and then the rest of it is what gets printed out there. Cool. Similarly, so I think we had the for loop use the match. Now the break timer, let's take a quick stretch. So our reduce, we could do this inside of the reduce as well. It'll work in exactly the same way. So if I took this, and instead of comparing it using greater than and less than, I could just use my regular expression that I had before, right about here, and that works in exactly the same way. Cool. Edgar's asked a great question, or Ed. I've noticed in almost all of your code katas you have reduce somewhere. Is there a particular reason you use it so much except for looking cool and showing more possible solutions? I will say it's definitely to look cool, because the code works with a for loop, right? A reduce is literally just hiding a for loop. When you're on a larger team of developers and more experienced developers, if everyone on the team understands what reduce is and how to use it, it's typically it's a less verbose way to write things. And so if you understand what it does, it can make your code look cleaner. But if you're new to coding and you've never seen reduce before, it can look very convoluted versus like something like this, which is very line by line doing exactly what it's doing. It's just a for loop. So yes, I'll say it's become a trend in the JavaScript world, especially if you see people like using React in more like functional programming. You'll see them using things like reduce. I'll be honest, when I first started coding in JavaScript, I barely knew how to use like map filter and reduce. Eventually, I got the hang of them, and now they're like my go-tos. Like instead of a for loop, I'll use something like map filter and reduce. But I'll definitely admit that it's a little bit trendy. So, yeah. Hey, Ashfaq, welcome to the stream. Oliver's saying YouTube chat is blocking less than signs, so you're trying to write code? Interesting. Oh, and hey, Dick. Thumbs up. So, yes, reduce is trendy. It looks cool. I like it. I tend to think in reduce now, but if you've ever seen me on something like code katas, I almost always like break it down. It's like, let's take this for loop and turn it into a reduce, which is basically just taking what's inside the for loop and putting it in there. One last thing I'll do, which is also a cool thing. So if we're talking about performance, split has to iterate over the whole string to break it up, and then reduce does another iteration. We can write this in a way that doesn't have to split it up first. So instead of splitting it, we can do this. We can say array.prototype.reduce.call and then pass in the string. And what this is doing is it's taking the reduce method that's on the prototype of the array and using the string as the internal instance and then doing the reduce inside of that. So instead of having to split it first, we're just directly using that function. And because a string behaves like an array, like when we wrote our for loop, strings in JavaScript, you can use bracket notation. They have a length. It's an array-like object. We're able to actually use the prototype method, which is cool. Okay, that was fun. Let's throw this into Code Wars and see what we get. Actually, I'll do the regular expression one, this one, all in one line. Sample tests. Works. We'll do an attempt. I got errors. Oh my goodness. Okay, let's see. Cannot read property length of null. Oh, okay. So one thing we're not accounting for is what if the string is null? Let's see. Do they talk about that in here? Oh, no, they didn't. What if there are no errors? Then this array is actually going to be it's going to be null because there were no errors in the string. Okay, so that's one thing we didn't think about, which is why we actually should, I'm thinking we could use this one because it does the inverse. But what if the string is only errors? This makes it a little bit more complicated. Let's see if this one will work. Okay, that works in the basic case. Oh, wow. Okay, so the inverse worked. But where I think this would actually fail is what if they send us a string that is only errors? Then this would actually fail. Okay, tricky tests. Question from Skelly, is there any reason to use const in a loop instead of let? Which one are you talking about? So for our iterator, for our index, this has to be let because we're modifying it, and const is a constant variable, so you can't change it. If you're familiar with let and const in JavaScript, there's a, I don't want to say it's a trend, it's a recommendation that pretty much any variable that doesn't change should be a const, and then any variable that does change should be let, and then don't use var at all. That's pretty much what the guidelines that I follow. Yeah. Oh, Oliver is saying their code passed perfectly fine. For the one that was the not regular expression, maybe because it's random tests. Let's try it again. Let me try it again. Because I know they randomize the tests, and every now and then, okay, so 3 failed, 3 errors, let's try again. 4 failed, 4 errors, try again. 5 errors, try again. 2 errors. I think because they're random enough, there might be a case where every single test case has at least 1 error in it. So I'll just go with this one. Oh, could it also be that I'm not doing... Let's see if we do it on 2 lines. Oh, you know what? I think we can make it work this way. So errors equals that. Or empty array. Because if this is null, then it'll get set to the empty array. There we go. I'll go with that one. Okay. Submit final. Drum roll, please. Great, we did it. Tonight I am drinking Club Mate. It's a beverage from Europe. I got it at a conference that I was at the other day. It's very good. Okay, let's look at some of the existing solutions. That's basically what we did. And then instead of using a template literal, they're using just string concatenation. Oh, interesting. They just checked if it's greater than m. They didn't check if it was less than a. But I guess in this case it works because the test strings are always giving you letters, not just like random characters. Oh, interesting. So what they do here is they do a replace. So replace all A through M with empty string, and that's going to give you a string that only has the errors in it, and then you get the length of that string. Very interesting. It's the longer break timer. I'm gonna let it sit up there. I do need a quick stretch. Drink some water. Cool. And then, oh, we didn't think about that. I was thinking of like this string could literally have anything inside of it, but apparently all of the test cases are just lowercase letters. So your regular expression could be N through Z because that's everything that's not A through M. Very interesting. Okay, moving right along. I feel like we spent quite a while on that one, but you saw lots of different ways to do it, so that was fun. Next one is sum of the first nth term of the series. So your task is to write a function which returns the sum of the following series up to the nth term. So the series is 1, 1/4, 1/7, 1/10, 1/13, 1/16. And essentially the denominator, I forget my math terms. What's the thing that goes underneath a fraction? Yeah, that's the denominator because it's down. The numerator is up. Denominator. Written below the line. Yes. So the denominator is increasing by 3. So the denominator here is 1 because it's 1 over 1. Then it's 1 over 4 because 1 plus 3 is 4. Then it's 1 over 7 because 4 plus 3 is 7. Then it's 1 over 10 because 7 plus 3 is 10. So the denominator is increasing by 3 each time. And we need to find the series up to a given number in the series and round to 2 decimal places. So for instance, if they say series sum 1, we need to return just 1 because we have to return the first number. If they say series sum 2, we need to calculate the first 2, sum them up, and return that number. If they say 5, we need to calculate the first 5, sum them up, and then return that number rounded to 2 decimal places. So that is what we will do. Awesome. Before I get started, a question from Andre. How important is solving algorithms for a successful career in web development? It's tricky because like depending on the type of job, you may not be doing algorithmic things like this all the time. Like maybe you're like centering text on a page, or like you're doing more visual things. But problem solving in general is just good in general. Like the more you practice these, the better you get at breaking down problems, the better you get at solving problems. So when you're faced with a more like concrete problem that you're solving, it's not algorithmic or mathematic, you can take what you've learned in doing problems like this and apply it to that. So I'd say it's pretty important because as a programmer, as a web developer, you're solving problems every day. They may not be always mathematical or always like algorithmic, but they are problems and you do need to break them down. So it's very important. Mhadi is saying it's percentages. They are fractions, so we're adding fractions together. I don't know. Let's bring this down. Create a new file. We'll call this series sum.js. We have our function, and we have some of our test cases. Let's turn these into console logs. Cool. Andreas, hello, welcome to the stream. Okay, so let's talk through this. So essentially, we are given the series number that we need to go up to. So ultimately, we need to iterate up to n. So we will, and we need a place to store like the running total. So let's say like a place to store the overall sum. Then we need to iterate up to n. And I'm going to keep track of the current denominator. So a place to store the current denominator. Denominator? I think that's right. And we will initialize that to 1. We'll iterate up to n. We will add 1 divided by the current denominator to the sum. We will then increase the denominator by 3 and repeat. And at the end of it all, we will return the sum rounded to 2 decimal places. Oh, and hey Bob, welcome to the stream. JT gave us a formula. I think, so after I write this loop manually, we can plug in the formula and we'll probably get back the answer instantly. But yeah, I'll write the code to do it first. Okay, so we need a place to store the sum. So we'll just say sum starts off at 0. Then we need a place to store the current denominator. So we'll say let current denominator. Did I spell that right? Starts off at 1. And then we need to iterate up to n. So I think maybe I'll use we could do a for loop that just goes from 0 to n. Or I could do a while loop and I need like an external counter. Let's do a for loop. Why not? We'll do a for loop. So I starts off at 0 while I is less than n. Now we need to add 1 divided by the current denominator to the sum. Don't forget to increment I. So we need to say sum plus equals the 1 divided by the current denominator. Great. And then we'll increment current denominator by 3. And then lastly, let me fix this error real quick. Lastly, we will return the sum rounded to 2 decimal places. So built into JavaScript is this toFixed function, which returns a string representing a number in fixed point notation. So if I say toFixed and pass in 2, that's going to give me 2 decimal places. So let's see how we did. I think we've done it. Cool. And JT sent us a formula. I think I'll search the web because elements of a series will actually give us a formula that we can just plug into and get the number back. But this does it. So let's just try this on Code Wars real quick and see if it works. Sample tests. That works. Do an attempt. That works too. Cool. But yes, it would be fun to use the formula, and then also we could turn this into a reduce. So we're reducing ultimately up to the number, we're reducing down to the sum. Yeah. But let's find that formula real quick. So this is elements of a series sum. Wait. Geometric series, is that what it is? Because each term can be obtained by multiplying the previous term by 1/2. And are we multiplying? We're not multiplying, we're adding the previous term. Summation? Help me out, JT. What should I search for? Oh, it's not the series sum. So JT is saying that equation gives you the values of the element, which will be 1 over n minus 1 times 3 plus 1. Where did you find that, though? Is there a formula we can use? Summation of squares. let me just write out what you have there and see if I can make sense of it. So 1 divided by, and then in here we have n minus 1 times 3 plus 1. The values of the element. Do you mean each? Oh, I see. In terms of, instead of keeping track of the current denominator, I see. Yes, okay. Actually, let me write it that way next. So I believe the formula that JT gave me is, instead of having to keep track of the denominator, you can use this formula to figure out like what is the denominator given your current value of n. So let's do this. Okay, so the thing we're going to add is going to be 1 divided by, and we have, I'll fix this in a second, but n minus 1 times 3 plus 1. Now in this case, it's not n, it's I. And in this case, I starts at 0, so we actually need to, well, I guess we could start it at 1 and say, well, it's less than or equal to that. There we go. And that does it. Thanks for that, JT. So basically, instead of having to keep track of what our denominator is, each time inside of the for loop, we have a little formula that'll give us the current denominator given the current value in the series that we're adding. Cool. All right. Let's turn this into a reduce. And we'll use this fancy one. So ultimately, I need an array that is of n length. So I could do array.from. Oh, we could do it recursively. Yes. I think I'll try to do that next. So I need an array. I then want to, and that array will have length n, so like length 1. And then I'll need to reduce it. We're going to reduce it down to the sum. And we're going to get each value right now, which is undefined, but we'll also get the index. And inside of that, we'll do this. Well, actually, we can just return sum plus all of this. And sum will start off at 0. So right now, we'll return this. Am I doing something wrong? So now instead I need to do I plus 1. I think I went wrong, went totally wrong somewhere. Because I is going to be the index. Oh, sorry, no. Yeah. So sum will be the total sum, because that's our accumulator. Each value in the array is undefined, and then I will be our index. So we need to say, we need to do I plus 1 minus 1. There we go. And then all of that we need to say to fixed on the end of it. Nice. Okay. This is very interesting. All right. I think I'll try to do it recursively, and then we'll move on to the next one. Okay, let's try it. So this is our formula, right? And let's think about how we might do this. So if we call series sum with 1, it should just return that value. So recursively, do we want to keep calling it with in -1, and we're returning all of those added together? So so like if n is equal to 1, may not be on the right track here, but we're going to return this of, actually, we're just going to return 1. Else, we're going to return series sum of in plus, I'm confusing myself. Oh, good call. And Macho just mentioned, because I'm doing I plus 1 minus 1, then actually it could just be I. And if I comment this one out, that one should still work. Yes. Thanks, Macho. Okay, JT is probably going to have to help me out because I have confused myself. Wait, why is this complaining? Oh, and then I'm missing that. There we go. And I think Macho was mentioning, yeah, because we're, our loop, not our loop, but our reduce, the index starts at 0, so we can just do this. Great. Okay, now how do I think about this recursively? So we want to return series sum of in, no, really we want to return in -1 plus this whole thing of in. So if n is base case is n equals 0, return 0. Okay. If n is 0, return 0. Okay. The tricky thing, though, is, or is it tricky? We need to call toFixed. When do we call toFixed? Because I think if we round it while we're calculating it, we're not going to get the right value. Let's see. Yeah, how do we do this? I guess we could do, like, if we tried to do toFixed here, that gets very tricky. But then this whole thing needs to get turned into a number. And then can we do toFixed here? And that's a number. Yeah, but then we get like this weird rounding error. Let's take a quick stretch. I think I might leave it there because I guess the issue is actually we want to return empty string. Okay, Oliver has a good suggestion. So pass in a second parameter which defaults to true, and then set it to false if you need to call toFixed. Okay, let's try it. Okay, so we start off here, and then basically we want to call it with true on the very last addition, right? So when n equals 1, we actually need to pass in true. So call this round. And initially it is Oh, defaults to true. And then when recursing, we pass in false. And we need to check to see because I'm thinking this defaults to false. And then on when n equals 1, we pass it in as true. Am I thinking right about that? No, I want it on the first iteration. Ah, okay. Okay, so I see. So when recursing, you pass in false. And basically, move the return value out of the if else. I'm so confused. Okay. Because if round is true, then we need return how do you get access to the previous value though? It's really hard for me to think recursively. Okay. So do we say something like if round else that broke it. Oh, I see. Assign the return value to a variable. Okay, that makes my life a lot easier. I see. Okay, so result is this. And then we'll return, so if round, then we're going to return result.toFixed of 2. Else we'll return the result. There we go. Oh. Awesome. And that does it. Okay, let's submit this to Code Wars. I think I'll submit this one. I like my keeping track of the denominator. Let's see if this works. Oh, we already tested that one. Okay. Let's test our recursive one then. Make sure that one works on Code Wars. Sample tests. It works. We'll do an attempt. Oof. See this error? Expected 0.00 instead got 0. Do I need to do that to toFixed? That will break it though, because if, won't it? Yeah. Oh, that. Because ultimately, I think this specific test is just passing in n equals 0. Oh, I can do the same thing, I think. Yeah, I can't see the code snippet, but here's what I think I need to do. I need to say, basically do the same thing. Let's do this. We'll have an outer variable, and then we'll assign it inside of here, and then the return goes outside. Hey. Okay. Let me make sure that I do this one locally. So basically, if they passed in 0, then this logic already handles rounding it in the base case. Cool. Jron mentioned 0 or 0, 0. That will actually always be 0.000, and then it won't be able to add it. This is the winner. Okay, submit final. Okay. So this solution is using a for loop and toFixed. Same thing, just like they swapped their formula around. Recursive solution. Whoa. Whoa. Okay. Are they actually passing in the sum? So if in, this is so clever. So because if in is ever 0, that's a falsy value. So if in is 0, then you're just going to return the total sum to fixed. Otherwise, you're going to recursively call series sum with the current summed value and then the next like lower in. So you're starting at the end and like working in. That's really cool. So Oliver's saying you could actually return 0.00 in the base case and move the function call to after the term in the addition so it casts correctly. Yeah, that's the main thing I'm worried about. Like if we set result as a string here, then in the recursive call stack, it's going to try to add a string to the running total, which is still a number. But I guess what you're saying, move the function call after the term. Oh, meaning put series sum after, so add, I guess what will that do? Because this will give us, I see. Because then, because the number's on the right-hand side, it will cast it to be a 0. Yes. Actually, so let me, I think that's where you're going with this. Let me just write it one more time and do it. So plus series sum, and then we can remove our return into here, and then in the base case we always return 0.00. Return 0.00 in the base case. Move the function call to after the term in the addition so it casts correctly. I guess that also parses it to a number. But does this work on Code Wars? Let me try it again on Code Wars. And is this what you mean, Oliver? Please clarify. Let's try again. Attempt. Yeah, that does it. Though really, we could have just parsed it as a number on the left-hand side. Okay. Submit final. All right. We have done 2 so far. I've been streaming for close to an hour. All right. Next one is a 6Q. Find the parody outlier. Okay. You are given an array, which will have a length of at least 3, but could be very large, containing integers. Actually, before I get into this, there was a question in the chat from famous ATB. According to your last map app with Leaflet, can you recommend any online course for Leaflet? I have never seen one. There might be some tutorials out there. As you saw, like when I did it, I just tried to use the docs as much as I could. I wasn't really following a tutorial or anything like that. Yeah, I don't know of any. Sorry, but maybe I'll make one now that I have a little bit of experience with it. Okay, let me see what Oliver was clarifying. I meant what you had before the additional plus, but I got the rules of JS strings wrong. Well, what I was thinking is if you do a, let's test it. I don't want to test it on W3 schools, but like here. So if you do a number plus a string, I think if there's a string anywhere in the expression, like the addition expression, it coerces all sides to a string. I thought depending on the side, like 0.00 plus 0, yeah, so it looks like no matter what, it coerces the thing that's not a string into a string. Is that what you were thinking? Yeah, okay. Not this one, this one. I think I can solve this one fairly easily. Let's see. This is a 6Q. You're given an array which will have a length of at least 3, but could be very large, containing integers. The array is either entirely comprised of odd integers or entirely comprised of even integers, except for a single integer in. Write a method that takes the array as an argument and returns this outlier in. Okay, so either everything in the array is odd or everything in the array is even, except for one thing. And you need to find that one thing. Let's do it. So this is called Parody Outlier. Bring down our tests. Okay. Here's what I'm thinking. First, we need two things. We need a place to keep track of the odd numbers, a place to keep track of the number of odd numbers, a place to keep track of the number of even numbers. So we can have two variables, or we can have an object with two properties inside of it. But basically, we're going to keep track of every odd we see and every even we see. And then we need to iterate over the array. Over the array, we'll say if the current value is odd, increment odds, else increment evens. I might swap that because it's easier to check if something is even. And then we'll say basically we need to detect, have we already seen a bunch of evens or a bunch of odds? And if we have, and this thing is not that, we found it. Modulus and check length of both. Not sure where you're going with that. JT says, I, for one, miss strong typing. I was thinking about that today. Like, I've been doing JavaScript so long. I'm just, like, used to it now. And, like, that's how I think. I started in Java, then did, like, C and C++, and then did C# professionally for, like, 3.5 years. So I was in, like, the statically typed world for a very long time. And now I'm not. And it's actually really hard to go back. Once you just start thinking so dynamically, like, and also like a like garbage collected language like JavaScript, where you don't have to think about the memory, and it's really easy to just like dynamically allocate things. I don't know. I should probably start writing stuff like that again because I haven't in a very long time. Oliver says, "Go for Rust." Got to go for Rust. Yeah, I'm thinking either Rust or Go. But Rust seems to have a very interesting memory model. Right? I think that's it, right? It doesn't have a garbage collector. It doesn't have reference counting, but it's like memory safe. I don't know. I'm going to stop talking because I don't know much about it. Okay, but now in our comments here, this is where we need to check. Let's say if the current value is odd, increment odds. else increment evens. Then we just say if number of evens is greater than 1 and number of odds is 1, we found it. Else, if number of odds is greater than 1 and number of evens is 1, we also found it. And we'll return that number. Okay. Let's get to coding. So a place to keep track of the number of odd numbers. So let's say let odds start off at 0. And then evens starts off at 0. Then we need to iterate over the array. So we'll have a for loop. We'll do a for loop, but this makes me think we can actually use a higher order method like sum. I think I think sum, because whichever one in the array. Well, no, probably use find, because we want to find the thing in the array that's not like the others, and find returns immediately, regardless. So I is 0. I is less than integers dot length I plus plus. So we're going to iterate over the array. If the current value is odd, increment odds. So I think I'm gonna swap this. If the current value is even, increment evens, else increment odds. So let's create a variable for the current value. So current value is integers at I, and we'll say if current value mod 2 is equal to 0, means this thing is even. So we'll say evens plus plus, else we'll say odds plus plus. Now comes the logic. If the number of odds is greater than 1 and the number of odds, if the number of evens is greater than 1 and the number of odds is 1, we found it. So we'll say if evens is greater than 1 and odds is equal to 1, then we found it. So we're actually just going to return the current value. Else, if odds is greater than 1 and evens equals 1, then we also found it. And we will return the current value. I guess really we could have an or statement in there, but for the most part, this should do it. Why is this complaining? Else if. And then that should do it. Because we should find it inside of the loop, and it should return at some point. So let's try it. Looks like we broke it. Mr. Tony, welcome to the stream. Oliver is saying, I only need the first 3 numbers to detect the regular parity. But I need to find the number that doesn't match, right? Right? Yeah, I think that's the main thing. So, oh, I see what you mean, though. So we could look at the first 3 numbers and say, are those 3 odd or are those 3 even? And then just look for the one that is not that. I think I'll solve it that way next, yeah. Yeah, Rust does sound pretty cool. I think I'm going to check it out. Okay, Saint Sean has some mod stuff. So x mod 2 not equal to 0, odd. X mod 2 equals 0, even. Wait, what did I do wrong? Oh, good call. Oliver's mentioning current solution doesn't work if the error is in the first 2, and that's probably why it's breaking. Because the error was here. So I need to look at least 3 numbers before returning the value. Okay. And if that's the case, I need to keep track of what the odd man out is in in a variable out here. Okay. So what's a better name for this variable? Let not like the others. And here, instead of returning it, we'll say not like the others equals the current value, or not like the others equals the current value. And then we'll say if I is greater than 2 and not like the others is defined, then we will return not like the others. Wait, what? Oh, very, very interesting. For whatever, yeah, and so JT is mentioning what Sean is mentioning, and I think I'll definitely do that because that's a good solution. But where my mind was going was, instead of iterating over the whole array, I want to stop the moment I find something that is not. So that way I potentially don't have to iterate over the entire array. I can just stop iterating the moment I find that thing. Let me work on my logic though, because it's not good. Oliver has it. Keep track of the last found even and the last found odd, so you can return the correct one when you enter those 2 cases. Okay. I like it. Last found even. And then we'll definitely do what Sean is suggesting, because we could do like a filter, and then yeah, it'd be great. We'll do it. Evens plus plus, so last found even equals the current value. And then odds plus plus, so last found odd equals the current value. And then if evens is greater than 1 and odds equals 1, then not like the others is going to be the last odd that was found. And if odds is greater than 1 and evens is equal to 1, then not like the others is going to be the last even found. And so, I think I still need a not like the others. Okay. I'm getting undefined. So it works in this case. That's great. But the case where it's within the first 3 doesn't seem to be working. There we go. Greater than or equal to 2. But in this case, we're getting undefined. Let's debug it. Because I will always be greater than 2 with those conditions. Oh. So let's just check, like, when we get to the 4th one, because I will always be greater than 2 with those conditions. If I is greater 3, 2, why is it breaking for this specific one? Because we would have found it when we got to I is equal to 3. Honestly, though, okay, I want to figure this out. This one's breaking. I think I'm going to use the debugger, but I have to use the restroom right quick. So I'm going to take a quick break, but I will be back in minutes. Don't go too far. Ask things in the chat. I'll be sure to check the chat when I come back. But see you soon. Hello. Comment from Oliver. Not like the others is 0, so the condition in the if. Oh! Oh! Good call. I think that will actually fix my. Yes, because not like the others is 0. And not like the others does not equal undefined. That's the one. Appreciate that. The previous if statements are already. I thought this was the case where. Oh, I see. Before I was returning the current value. I don't want to return the current value. I want to return the last found even or the last found odd. That's why. This, yes. This goes away. Yeah, that's the winner. And then I don't need to keep track of that anymore. Okay, great. Appreciate your help. And so the reason I coded it this way and the reason I like this solution is the moment we find the thing that's not like the others, we instantly return it, and it's less calculation. But I do want to try what St. Sean suggested, which is essentially group the numbers into evens and odds and then check their length. And so whichever has the longer length, then we'll return the value inside of that array. So let me try this solution on Code Wars right quick, and then we'll try the next one. So sample tests, it works. We'll do an attempt. It works for complex tests, for random tests, for really big numbers. Cool. But let's try using like a higher order method. So we'll have our function, and we get our integers. And what we're thinking here is we'll have a place to store the odds, have a place to store the evens, and then iterate over the integers. If even, push into evens. If odd, push into odds. And then at the end of it all, whichever array is length 1, return its first value. Let me double check all the comments to make sure I'm accounting for that. So if even add to array, if odd add to array, return even length greater than odd. Yeah, so I think we'll do this first with, yeah, and then we're gonna, the one with the smaller, in this case, the length, we know it has to be 1, and we'll return the value inside of that. We could definitely do this with a reduce. We could do this with multiple filters. I think first I'm gonna do it with a for loop, and then we'll write it the other ways. Quick stretch. Okay, so we have odds, and that's going to be an array. We have evens, and that's going to be an array. And then we need to iterate over the integers. So we'll have a for loop. I goes from 0 while I is less than integers.length. I plus plus. Okay. If, let's grab a variable for the current value. So current value is integers at I. If the current value is divisible by 2, then it's even. So we'll say evens.push current value. Else, push it into the odds. So odds.push current value. And then at the end of it all, yeah, I mean, I think technically though we could do a very similar check in here, right? Yeah, I think so. So instead of waiting till after the for loop, we can just do it here. So we can say if evens.length is greater than 1 and odds.length is 1, then we can just return odds at 0. Otherwise, if odds.length is greater than 1 and evens.length is 1, then we're going to return evens at 0. That still works. Very interesting. So instead of having separate variables for the number of odds, the last one we found, we simply just are storing it in an array. Now, I don't think this is exactly what Saint Sean was mentioning that I do. However, using that similar logic, this is actually it's just as performant because it immediately quits the moment that we find something. Let's also write it by checking after the for loop. So instead, I think you had like a ternary. So like if odds dot equals 1, then return odds at 0, else return evens at 0. And that should do it too. Okay, Oliver is going to post their solution. I don't know how it's going to look in YouTube chat. While we're at it though, let's turn this into a reduce. So ultimately, this one is reducing mean, it's reducing this array down to a single number. But we could do a reduce because we're reducing to like two separate arrays. That will work. But if we want something that like quits early, like I currently have in the for loop, then we would need to use something like find. Oh, actually, I don't see your code, Oliver. I think maybe YouTube chat filters it out. I just see my solution was this. JT, yeah, so JT says you should build a code submission supplemental app for your stream. It's like similar ideas have been suggested before. I think I definitely want to, because it could be almost like, yeah, like I'm coding this and then I could open up a tab and see like what everyone else has coded and like they show their solutions as well. Or if maybe I'm not doing code katas, but I'm like coding on something else and someone has a suggestion, they can like throw it in there and I can like pull it up on my screen. That would actually be really cool. I'm gonna add it to the list. Okay, let's do this, but let's do it with a find, like Oliver mentioned. Okay. Honestly, like this code's kind of ugly. We can make it much prettier. Let's get rid of our comments first. Though actually, a find Oh yeah, Oliver. Yeah, if you post it in the Discord, I'll pull it up and actually, do I have Discord open? No, I don't. But I'll pull Discord open and take a look at the code. But I'm thinking with a find, what if you have to go past the number to know that you found it? How would find work in that case? Let me pull up in Discord. This is a very nice solution. Okay. Whoa, what's happening here? Parody is the array at 2 times the array at 0. Okay, let's break this down. Okay. And actually, that got rid of the comments. In a moment, I'm going to try to convert this into like a reduce or something like that. Okay. let's break this down. For one, are you doing like bitwise operators? What is happening here? I've never used this or seen this in JavaScript code. So you take the first value in the array, so let's say we take 0, and you raise it to the power of the second value in the array. And then, please tell me, Oliver, because I don't really know what this is doing. Is this a bitwise operator to figure out what? What is happening? Bitwise to get the first bit. So if we get the first bit of the value and multiply it by 2, and then that will give us another value inside of the array, and then we do another bitwise exclusive OR that gives us the parity of the entire array. I don't even know how to explain this. I appreciate the solution, but this is super tricky. But I guess once we figure out what the parity is, I don't know. Did you find? Oh, I see. Okay, so a simpler way to think about this is If the first two numbers are even, then we know that we need to find an odd number. If the first two numbers are odd, then we know that we need to find an odd number. If the first two numbers are even and odd, then we need to look at the third number and decide if, I don't know. I see. So what Oliver's saying is this part here, this is going to give us 1 if the first two numbers have different parity, meaning the first two numbers are even and odd. Otherwise, it's going to give us 0 if they have the same parity. And if they're different, the real parity is given by the second thing in the array, the second index. Otherwise, it's the first thing in the index. Okay. That's a little bit easier to digest, but basically, we look at these first two. Wait, is 0 odd? What is 0 mod 2? Technically, 0 is even, I guess. Okay. So in this case, 0 is even and 1 is odd. So we have to look at the second indice to know if the parity is going to be even or odd. Same thing here. In this case, the first two are even, so we know that the parity is going to be the opposite. Super interesting. Okay. What I was going to do was try to convert this into a, I guess not a reduce. I mean, I could use a reduce, but the main thing about a reduce is we have to iterate over the whole array. So really, this is the one that we're going to need to turn into a reduce. Let's do that. Ooh. Okay, let's get rid of the comments. Okay, so integers, we're going to reduce it into two arrays, odds and evens. Take a quick stretch. So we're going to return. Are we going to return? Yeah, we'll do this. We're going to return integers dot reduce. Let's call this grouped, and I'll show you what that means in a second. And we're going to get access to each current value. And our accumulator, this thing called group, is going to have two properties, odds and evens, like so. Okay, and then this code can go inside of the reduce. We may not be able to do it all in one line. And here, this is going to be, actually I can destructure this to give us odds and evens. And then the thing we need to return every time is an object with odds and evens. And I don't think I can do it on one line because I need access to I need to check it, then access it. So let's actually store this in a variable. So grouped is the reduction. And then at the end, well, actually, the reduction is to odds and evens, so I can destructure it. And then that works. How cryptic is that? So integers is an array. Our accumulator is an object that has two arrays in it, odds and evens. And then we're getting access to each value. And then if the value is even, we're pushing it into evens. If it's odd, we're pushing it into odds. And then we compare the two arrays at the end. Whichever one has a length 1 is what we want to return. Cool. We could also use, I'm just thinking multiple filters. Like we could filter for all even values. And then, what I just thought. So filter for all even values. Well, then you'd have to do multiple filters. So filter for all evens, filter for all odds, and then whichever one is length 1, you return. The issue with that, though, is it's multiple iterations of the array. So you have to iterate once to find all the evens and then another time to find all the odds. Using a reduce like this, we're finding evens and odds all in one go. Let's just do it with the filter to see it happen. So let's say odds is going to be integers.filter. We're going to get the value, and we want to return is that value. Well, let's get evens first. Let's get rid of all this. So we're going to filter the integers, and we'll say if I mod 2 is equal to 0, that's our evens. And then our odds are I mod 2 not equal to 0. And so that does it in 3 lines, which is nice. The only issue, which I mentioned, is this is multiple iterations of the array. We have to iterate it once to find evens, iterate it again to find odds, then we have our answer. Whereas this reduce does it all in one single iteration, and then we have our answer. But then if you compare that to some of our earlier solutions where we return inside of the for loop, this one is potentially a lot faster because the moment we find something that doesn't match, we immediately return it instead of having to look at the array, the whole array. Cool. I have also spent a very long time on this one too. Let's get on to the last one. Any last thoughts, questions, comments in the chat before we move on to the very last kata of the night? And I'll definitely leave Miamsumi's solution in here so you can check it out. Is that how you spell that? Miamsumi. There you go. This one looks the shortest, but the issue that I have with it is that it's multiple iterations. Miamsumi's solution is efficient in that a find immediately exits the moment it finds that thing, instead of having to look at the entire array and then returning something. Okay, which one am I going to submit? I think I'm going to submit the very first one that I wrote. Let's do it. Oh, wait. I already did it. Submit final. Yay, we did it. Oh, look at that. So one of the most common solutions is to do like 2 filters and then check the length. As I mentioned though, if you have like a really, really long array, you have to go through the whole thing twice instead of just going through it once. Interesting. So slice grabs the array. Oh, I really like this. Okay. So get the first 3 things in the array. And then if all 3 of them are even, meaning the first 3 things in the array are even, then we know that the odd thing is the one that we need to return. So you find the odd thing. Otherwise, if the first 3 things were not even, then we know that we need to find, we're not even, meaning 2 of them were odd. then we need to find the even one. I like this because this filter is only over 3 elements. Yeah, 3 elements. And then this find immediately finds the one that you need. So that's pretty cool. See a filter again. A filter. Oh, a filter while they're finding the result inside of the filter. Interesting. All right. Regardless, on to our last one of the night. I think this one is also going to be pretty tricky. But this is called first non-repeating character. Write a function named first non-repeating letter that takes a string input and returns the first character that is not repeated anywhere in the string. For example, if given the input stress, the function should return t, since the letter t only occurs once in the string and occurs first in the string. As an added challenge, upper and lowercase letters are considered the same character, but the function should return the correct case for the initial letter. For example, the input stress should return a capital T because T was capitaled in the input string. If a string contains all repeating characters, it should return the empty string. Okay, let's get into it. I'm going to bring it down locally. Let's create a new file. We're going to call this first non-repeating character.js. There's our function. We'll grab some very simple tests. Let's start up Quokka. Right now our function returns undefined. Let's do it. So my initial thought for this is we need to first count up all the letters in the string. So iterate over the string and keep track of every letter that we've seen before and how many times it has occurred. That's one iteration. Then we iterate again, and for each letter, we check basically where we kept track of if we've seen it before, and we check to see, does that appear more than one time? And the first one we find that doesn't, that only appears once, we return that letter. So I think that's what I'll do. So first we need to iterate over the string. And we'll need a place to store the count of each letter. And as we're iterating over the string, we'll say increment count of current letter. After we're done with that, we'll have all of the counts, and then we'll iterate again. And we'll say check the count of the current letter. So we'll say if the count of the current letter is 1, then we need to return that letter, meaning it only appeared once. And it was the first one to appear once. Okay, right now we're not going to handle uppercase and lowercase. That is where I think it's going to get a little bit tricky, but let's do this. So a place to store the count of each letter. We'll have this thing called counts. It's just going to be an object. We need to iterate over the string. Really, we could do this in a reduce. This is the last one of the show. I'm just going to do it all in one go. So counts is going to be S. We're going to need to reduce the string. So I'm going to do array.prototype.reduce. And we're going to call that on that string. We're going to get the counts and each individual letter. And this accumulator needs to start off as an object. And ultimately, we're going to return the counts. But inside of here, we're going to say counts at that given letter equals that itself, or starts off at 0. And then we increment the counts at that letter. So what this gives us is an object that has each letter as a property, and the value is the number of occurrences of that letter in the whole string. Cool. So we have the counts. Now we need to iterate over the string again. So we are going to Actually, we just did that. So now, actually, we can use a find here because we're going to look at every letter in the string, and the first one we find that has a count of 1 is the winner. So we'll say array.prototype.find, and we're going to call that on the string. We have a function that takes in each individual letter, and we're going to say we found it if the counts at that letter is equal to 1. So this will give us the very first letter in that string that only appeared once. Cool. So this does it. The only tricky thing about this is, what if we start to introduce capital letters? Let's just try this on Code Wars real quick, and then we'll see that it's probably going to fail whenever they start passing capital letters in. So for the sample tests, great. Oh, okay, so we're not accounting for handling empty strings. So let's do that really quick. So if it's empty, then just return the empty string. Question from JT. How do JavaScript's dictionary return keys? You could iterate then over the unique letters. Oh, that's. I think I get where you're going with this. The reason I built this up first and then now I'm reiterating over the string is I'm pretty sure that it depends on the JavaScript engine how it stores the keys. Like, it might actually store them alphabetically. So I don't know which is the first one that has a length of 1. Pretty sure. Like, if we... And I think it actually depends on the JavaScript engine. Like, you can't guarantee what order the keys are going to be in. Because you're right, I could just... If it did it that way, I could just iterate over the keys, and then the first one that is 1, return it. But what I'm thinking is... and it looks like the way it's logging it, it's actually keeping those keys in the order that I found them. So technically, if I just returned the first key that had a value of 1, that would work. But my only thought is, if we're running in a place where that doesn't happen and we can't guarantee the order of the keys, then we would need to iterate over the string, because we need to find the first one that matches that. I'm going to keep it that way for now. But okay, so now we're accounting for empty string. Oh, should handle all repeating strings. Okay. So if everything is repeating, then we return the empty string. Okay, that's great. Now, the capital letter situation. Wait, expected comma instead got capital G? Okay. Oliver's saying you could use a map that guarantees order, but not sure if the Katas node version has them. So this only supports version 6. So map is a JavaScript data structure that holds on to keys and values, but it actually does maintain the order that you put the things in. But I don't think we have access to a map in here. That would actually, it would make it faster though, because and actually, I mean, I really could even no, I'm thinking, so like, keep track of the ones that are currently 1, and then after looking at each letter, see if anything is still 1 and anything is more than 1, then it's the first non-repeating character. I don't know. But now we need to handle uppercase letters. So what should we do? So when we store it in counts, I think we should set it to 2 lowercase. So let's say letter equals letter.to lowercase. And actually, let's use the example case here. Stress should actually return capital T, so we can test it with that. Okay, right now it's returning R, but we want it to return capital T. So we're putting the letter in there as lowercase. And then we want to check if letter.to lowercase is equal to 1. And that does it. Is it really that simple? Let's see. Hey, it worked. Oh, Oliver's mentioning Node 6 does have map. Okay, let's try to use it instead. Ooh, quick break. So if we're using a map, then actually I need to look up how do we use a map. I'll say new map, and then you do like map dot add, or what do you do? Can you just use bracket notation? Map dot set. Yeah, okay. So we're going to reduce to a new map. And wait, can you do bracket notation on a map? No, you can't. Okay. I guess I have to, my logic will get a little bit more complex because I need to see if, yeah, we'll say has key. So if counts.has the letter, then we're just going to say counts.set letter to be counts.get letter. So get the current value and add 1 to it. Else, we're just going to actually, oh, we can do this as a one-liner. Counts.get letter. If we get it and it's undefined, then we'll just make it 0. So if it's not already in there, 0 plus 1, so that should do it. And then now, instead of having to iterate over the string, we can do, I guess, like a for in. Does this give us each individual letter? Can you for of it? So this gives us the entries. Okay. And then really we could destructure it as the letter and count. And we'll say if count is equal to 1, then return the letter. Oh, this the issue with this now is I'm not maintaining the whether it's an uppercase or a lowercase. So we can make it work though. Basically what we need to do is our map should store uppercase and lowercase. And then when we're checking, we need to check and see if the combined total of uppercase and lowercase is equal to 1. Okay. So if count equal 1 and counts.get letter dot, well, actually, let's do this. Yeah, I guess what I was doing before is just returning it. Yeah, Oliver's saying store uppercase and lowercase version of all letters, maybe. That, I guess that could help. So basically, then when you're checking... So our map includes both uppercase and lowercase a, but with the same count for both. And then... yeah, that way, okay, let's see. So, let's do this. So we're going to set that to be that. I guess we need to flip it though. So store it as, let's do this. Store it as lowercase and then store it as uppercase. So we're always storing both. So and then JT is saying, or you could just switch the case if the entry already exists. That way you know the first is upper or lowercase. What do you mean? I'll be honest, it's really hard for me to think about this right now. So now we're always storing it as, we're storing both. But we need to, but do we need to store it as upper first or lower first? I guess in this specific case, if we store the upper first, then that one always gets returned. Okay. Before, this is what I was doing. Okay. Switch the case if the entry already exists. That way you know the first is upper lowercase. Okay. I don't know. So here's the thing. Using a map has now made my life a lot harder than just using an object and iterating again. But okay. So JT is saying, yeah, the problem is you need to know you need to know the case to know which to return. Okay, Oliver's saying, store the string, then lowercase, then upper, and check for equals to. You know what? No. I think I'm gonna call it there. I'm gonna leave it as an exercise for the reader. If you come up with the solution for this, throw it in the Discord. But I'm actually gonna get home a little bit early tonight, so I think I'm gonna go ahead and call it there. I really do appreciate all of the suggestions in the chat. This has just melted my mind, and I need to step away. So I'm going to do that. I mean, technically, though, we use the map, and then if we do it the searching through the string way, then that technically works. Oliver says, it would be the worst possible code. That'd be fun to have a competition so you can write the worst code. But yes, I'll push this to GitHub. It will be an exercise for the reader. But I think I'm going to call it there. I will submit this one on the Code Wars. Submit final. We did it! Cool. Oh, interesting. They used a regular expression. Oh. This is extremely unperformant. Yeah, and JT is mentioning in the chat, it's almost like they write these so they have weird edge conditions. When you get to like 5Q, 4Q, absolutely. It's like you have to account for so many different things and make sure it works in every case. Because they actually have similar problems that are like 7 or 8Q, but it's like you don't have to worry about uppercase, lowercase. But now when you do, things get tricky, or if you have to worry about punctuation, things get tricky. So yeah. However, I just want to comment on how not performant this is, because we're doing a regular expression match inside of a for loop. So this is like basically a nested loop. So we're saying for every letter in the string, search the entire string for that current letter that we're on. And if the length is 1, return that string. And if that wasn't the case, go back around and try it again for the next letter. And if that wasn't the case, go back around and try it again for the next letter. So this is like in squared, lots and lots of checking. And it saddens me that this is the most, like, the order these are in are, more people have submitted them. And this is saying sorted by best practices. I do not agree. I do not agree at all. Because this is like a nested loop, essentially. Another nested loop. What is up with all this nested looping? And like the thing is, it's a nested loop in disguise, because index of has to search the whole thing to find the index. So this is like a loop inside of a loop. And then this one, it's using like a substring. These are all horrible. Do not look at these solutions. Yeah, and so Oliver is mentioning theirs is n squared. Let's see. Yeah, and that's the one reason I kind of want to write it at least like with an object or something like that, because if you're doing something like a find inside of a find, then it is like n squared, meaning it's going to take a bit longer. So turn the whole thing into lowercase. Actually, I'll throw this into VS Code. And I'll leave a note. Make this work. Okay, turn the whole string into lowercase. And then we need to find the index where, so turn that into an array and then find its index where the last index of that character. So last index of will find the last index in the string. And if the last index in the string matches the first index, then we know that that thing only shows up once. And so the one we find that is that case will be the first one, and then we're going to grab that as an index out of the array. But yes, this is like nested looping. But it does sadden me that most of these these top solutions are all like n squared, meaning like nested loops. Cool. All right, I think I'm gonna call it there. As I mentioned, I will push this code up to GitHub, links in the description. Thanks everyone for watching. I think I'm just noticing My Flux has been on this whole time. Sorry. I forgot to turn it off. Yeah. Well, actually, Amy, we are over now. Thanks for tuning in, though. I probably won't stream tomorrow because I have to do laundry and I have other stuff going on in my life. So absolutely expect a stream on Saturday. I might actually do like a morning tea. I haven't done a morning tea stream in a very long time. So expect maybe one of those. I'm trying to stream when people across the world can tune in, because I know a lot of people wanted to tune in tonight, but they're like, it's 2 a.m. and they're sleeping. So if I stream at like 10 a.m. on Saturday, it's more doable for those people. And then me and Tony may stream Noob Quest on Saturday. Don't know for sure. Watch the channel. I'll let you know. Let's see, view my channel. Yeah, any upcoming streams, I'll throw them up here so y'all can tune in. Ed says, nice stream as always. You're very welcome. And maybe a stream on Friday. I don't know. I'm so busy. I'm so exhausted. Like, I cannot stream as often as I had planned or had wanted to, moving out here to New York. But I'm only here for another like month and a half, and then I'll probably have the time again to stream 5 days a week. And Andreas, you're very welcome. Thanks everyone else that tuned in. Saturday streams are happening for sure, but like I said, check out the channel to see upcoming streams. And I'm really close to 2,700 subscribers, so yeah. And Winkle, you're very welcome. Yeah, again, thanks again, everyone, for your help, your suggestions. You are all wonderful people. And wherever you are in the world, have a wonderful morning, afternoon, evening, or night. I'll see you next time. Here's this.